Hey everyone, welcome to The Explainer. Today, we're diving straight into Loki Laboratories' brilliant blueprint for completely revolutionizing legacy manufacturing. We're looking at this fascinating collision between some of the oldest, heaviest industrial processes on the planet and the absolute bleeding edge of artificial intelligence. It's a really cool concept, so let's get into it.
So how exactly do you bring a traditional, highly polluting industry like cement manufacturing into the AI era? Well, to understand the fix, we first have to diagnose the underlying problem. Just think about the sheer physical scale of this space for a second. This is an industry that literally shapes our skylines, right? It forms the solid foundation of our modern world. And yet, incredibly, its core processes have historically relied on a huge amount of archaic guesswork and, honestly, just an unbelievable amount of waiting around.
In standard cement manufacturing, doing quality testing in a laboratory creates this massive, dangerous delay of anywhere from 2 to 24 hours. Just let that sink in. You're running this massive, continuous, extremely hot production line churning out thousands of tons of material, but you have a blind spot that can literally stretch for an entire day while you wait for lab techs to manually test physical samples. It's basically like driving a colossal, speeding industrial vehicle while totally blindfolded.
And that brings us to our first core section, the cement industry problem, and why this costly delay is crippling modern manufacturing. The contrast between the old way of doing things and the new AI-driven approach is pretty stark. On one hand, you have the traditional reactive linear flow. You produce the cement, take a sample, ship it off to the lab, and eventually, much later, you get a report. But with an AI engine, you bypass that entire waiting game. You jump straight from production to instant quality prediction. It completely severs that reliance on delayed physical lab reporting. Loki Laboratories really hits the nail on the head here. They point out that by the time results arrive, thousands of tons may already be produced. The financial and environmental waste generated when you're churning out suboptimal cement while just waiting for a lab report is staggering. If your mix was even slightly off during that blind spot, you've just wasted immense amounts of unrecoverable energy and highly valuable raw materials. No way around it, it's a huge loss. Which brings us to the solution in Section 2. Meet the Smart AI Engine. This is where proactive manufacturing actually becomes a reality. So, instead of waiting around for isolated, sporadic tests, this platform constantly digests real-time data. It's continuously pulling inputs directly from the factory floor's SCADA and DCS systems. We're talking about monitoring the mill feed, separator speeds, fan loads, temperatures, basically the physical pulse of the factory. It combines that massive stream of operational telemetry with raw material chemistry and whatever lab data is available. It's a system that never sleeps and never stops paying attention. And behind the scenes, there is some incredible computational muscle at work. By feeding these highly specific data points into advanced machine learning algorithms like Random Forest, XGBoost, and CapBoost, the system processes everything instantly. It achieves something that was previously thought to be impossible in heavy manufacturing. It actually finds the hidden mathematical patterns buried deep within the pure chaos of an active industrial plant. Now, imagine knowing your 28 days cement strength immediately. The AI uses those underlying patterns to predict critical quality metrics right on the spot. You don't have to wait nearly a month to know if your product meets the absolute highest structural standards anymore. The AI calculates the 3-day, 7-day, and 28-day strength plus blane and setting times instantly. It completely wipes out that dangerous 24-hour testing blind spot we talked about earlier. What's really cool is how this translates into a unified dashboard. It brings the whole shebang together. Production, quality, cost saving, and CO2 reduction are all right there in one single coherent view for the plant head. The data sits right alongside the quality team's alerts and strength predictions, so it isn't just a bunch of abstract code, it's a tangible control center. Suddenly, everyone from the floor operator to the executive is operating from the exact same instant playbook.
Let's move to Section 3, Tangible Optimization and Benefits. Because we really need to ground this incredible technology in reality and look at the actual, measurable impact on the factory floor.
First off, we have to understand this system isn't just some generic tool. It is highly specialized. It actually customizes its optimization based on the exact product currently running through the mill. So, if you're making ordinary Portland cement, or OPC, it aggressively pushes for maximum throughput and cost reduction. But, say the plant switches to Kawach cement, the AI instantly pivots to control entirely different unique variables, like extreme durability and crucial water resistance. The AI is essentially acting as a tireless virtual plant manager. It issues precise, data-backed directives in real time. For example, it might tell the operator to reduce expensive carbon-heavy clinker to 65% while increasing fly ash by 2%. It's constantly fine-tuning the dials to find the absolute perfect, most cost-effective chemistry every single second.
And the results of those relentless micro-adjustments? Absolutely profound. Saving 15 rupees per ton, reducing CO2 emissions by 20 kilograms per ton. Now, when you're manufacturing millions of tons of material year after year, those specific numbers add up incredibly fast. It literally transforms the basic economics of the entire plant.
The big takeaway here is how perfectly this tech marries ecological responsibility with hard business efficiency. By mathematically lowering the clinker factor and drastically reducing energy consumption through AI optimization, you are directly lowering your carbon footprint. Green manufacturing and profitable manufacturing finally become the exact same thing. To put that into perspective, we really have to look at the scale. When you scale those per-ton savings up to a standard 2 million ton per annum grinding unit, the raw material savings alone just explode. We're talking between 6 and 12 crore rupees annually. Add to that up to 5 crore in pure power savings. That's a return on investment that doesn't just improve a quarterly spreadsheet, it completely shifts the operational paradigm of the heavy materials industry.
So where is this all heading? Section 4 takes us into the future of manufacturing and Industry 4.0. Because honestly, predictive dashboards and automated recipe tweaks are just the beginning.
We are moving way beyond standard dashboards and stepping into the era of Copilot AI agents. Using tools like Microsoft's Copilot Studio, Loki Laboratories is enabling dedicated quality and production agents, meaning you can literally converse with your factory. You can ask it why a specific strength dropped overnight, or why the mill throughput suddenly reduced without warning. It's wild.
Instead of digging through endless spreadsheets, a plant manager gets this beautifully simple workflow. Step 1. You just ask a question in plain English. Step 2. The AI instantly analyzes that massive, complex stream of real-time SCADA and lab data. And Step 3. It automatically spits out the exact, precise setting recommendations you need to resolve the issue on the floor. It's really that straightforward.
Just imagine typing a highly specific query into a prompt, something like, how can I reduce my PPC cost by 20 rupees a ton while maintaining my 28 days strength? Instead of forming a committee, holding a bunch of meetings, and running a week-long physical test, you just watch the AI instantly calculate and adjust the feed rates and separator speeds autonomously to hit that exact goal. That is the raw, game-changing power of generative AI applied to the industrial space.
Ultimately, what Loki Laboratories has built here is a complete, holistic Industry 4.0 ecosystem. They've seamlessly fused quality control, production optimization, digital twin simulations, and massive cost reductions into one unified platform. It's a comprehensive blueprint that proves a really profound point. Right now, data is literally the most valuable raw material in modern manufacturing. Which leaves us with a fascinating question. If a self-learning model can tame the intense, volatile complexities of a massive cement plant, slashing emissions and saving millions of rupees in the process, what legacy process is waiting to be transformed next? Honestly, no traditional industry is off limits anymore. Thank you so much for exploring this with me today. Keep questioning how the future is being built, and I'll catch you in the next explainer.